Okay, hello everyone. Let's start today's discussion. Today we are getting into a part of engineering where things get a little bit interesting. So basically, this is where the technology meets the ethics. You can think of it like like we are not just building machines anymore. Basically, we are building the systems that make decisions. And that means we've got to ask not just that can we build it, but also should we build it like that? Now, this is where the IEEE 7000 series comes in. So it's a whole set of standards that helps us to think about the right way to build the emerging technologies. Is not just like how fast something works or how much data it crunches. It's also about making sure what we build is actually good for people. Now, there are a few quick things to keep in mind. One is that this series actually is the aim is not to replace the other standard like IEEE 1680 or 1547, and it's basically wanted to like complete them but covering the ethics and like social impacts. So another thing to make sure that we know is that these standards basically matters now more than before. So, and that's because we are working with like an AI or automation system. So there's stuff that actually making decision in real world. No, and another part is that we are basically in our industry at a turning point. So we're building the system, okay, that basically they could like teach people or judge them or hire them. So ethical side is very important. Uh, Now let's move on to our discussion. Let's talk about why actually this standard even exists. So before this standard, okay, the engineering were all about stuff like measuring the efficiency or the quality of the work or like safety, the accuracy of our system. So basically that was working, okay, but it didn't kind of like cover the changes in the technology that came in the recent years. So we had AI, we had autonomous car, we had some surveillance system, and all of them basically affect the people's life. Is not just hardware. So it's not just about to make sure that system works. This is not the only goal that engineers should have. Also, they should make sure that those systems like respect privacy, or they are if they are making decision or judging a certain aspect, they are fair, and whether it's and make sure that they are actually making some responsible choices. Now, this is basically when this standard IEEE 7000 series was developed. So we said that, okay, we need something more. So we basically developed something that we call it ethically aligned design, okay, EAD. That helps us to bring some ethics into the design that we have and the process of designing. Now, instead of basically just doing some math work, the standard, the IEEE 7000, help us to check the system and see if it's transparent or fair or respectful. Okay, so and it should happen from the start to the end of the life of the device. Now, let's look at this significant shift that we have in thinking. So there is a core philosophy into that IEEE 7000. So all the traditional standards and other standards are basically mostly focused on the technology, but this IEEE 7000 series started to actually care about the human values and the user's value and the user's safety and privacy and well-being when they use actually those technologies. So basically, it says that every system that is designed by the engineers, it could be a chatbot, it could be a delivery drone, or like a autonomous cars or surveillance system, or even financial algorithm. That system basically should also reflect some kind of like priority or belief. So we have to make sure that the values that the system represent are good and ethical. So what that means in real life, let's talk about it. Now, the technology, please pay attention, the technology is not, it is actually never neutral. So it doesn't matter if we realize it or not. All those systems, to do their job, they make some choices. Okay, so the way that they make those choices is basically a reflection of someone, the designer actually, thinking, and is important. Okay, now another factor is the transparency. Okay, this is not just a luxury, this is a requirement. So people should be able to see that how that system works or make decision and how all those results will be made for those users. The other factor in the philosophy of IEEE 7000 is the accountability. It's not just about the software. Okay, so uh, it is actually exists that the team or organization that work through the life cycle of that technology are also have like an ethical level too. So basically, everyone involved should know what they're responsible for. Now, another fact is that we need to respect people. Okay, so that's when user dignity and the agency comes in. So those systems should not basically push the user around or trap them. So the aim is to help people. Okay, so we can influence by force their decision. So we need to like give them the ability to make their own info decision, and even provide them the resources to actually do that decision by having all the information of like pros and cons of options. Okay. Now, the structure of IEEE 7000 series has several kind of like aspects. One is that it includes the process standards. So this part actually try to help us through the steps for making sure that we meet all the ethical requirements. okay, through the development of the product. Okay, so this is not just one step work. After that, we have some domain-specific standard included in the IEEE 7000 series. So on that part, this standard basically zoom in to understand some particular issues, okay, based on the technology and the field that the system, that targeted system would work. Okay, so the requirement, for example, for surveillance system might be different with the requirement for like a financial algorithm, like the algorithm that controls the trade market, or algorithm that actually decide that you are pre-qualified for a loan or a credit card like that. Okay, so these are also the system that we develop, and there are, as you can see, there are several aspects, the ethical aspect that could affect people's life, okay, in certain levels, uh, and we have to make sure that we meet all of them. So this part is basically domain specific, zooms in into each field and each technology. Now, the next part is some emerging technology standards. Okay, this part actually try to take care of the newest stuff. Okay, now if you you know, like that recently we have virtual reality that kicks in into the technology, or AI is also thriving in recent kind of like years. So basically that evolvement, which is actually a fast involvement in the technology, create a need uh, for some ethical backup. So we need to also address those involvement in and make sure that the new technology or enhanced technology also meet those ethical requirement. Now, it's not just like a one rule book. Okay, so this series, the 7000 series, is a collection of all the related standards. Okay, and you can basically, based on what you are working with, you can mix and match those requirements. Okay, now each of those requirements that we create and we have actually in this IEEE 7000 series, they have a clear kind of like a structure. So it should be a clear definition when we're talking about the statement and articulation of those requirements. Okay, there is a validation metrics, okay, or like parameters, the quantitative parameters that we actually can use for validating the design. Okay, there is a system diagram, okay, for a specific system that helps you to actually plan what should happen during the life cycle of that system. And there are tools to run the test, the procedures, the kind of like the process of testing, the validation methodology. All those are defined in the standard. So when you want to talk about the validation and check those metrics that you had for designing, you can use these testing tools to run that evaluation. And it's not just that, there is also a reporting kind of like tools in this standard series. So when you test your system to see if you are complying with the ethical aspect of your design, okay, there is a reporting obligation that you have to report the result and the way that you come up with that result. Okay, so there is a very good transparency between the designer, the auditor, and the user. Now, Let's talk about the application domain. What is the scope that IEEE 7000 actually covers? Now, the short answer is that it covers basically pretty much anywhere that the machine or the system, the technology that we develop, interact with the people. Okay, so when we have a system that uses the data, or as we said, making decisions, or has any level of like autonomy, okay, then this standard would comes in to make sure we have like a certain level of ethical consistency and compliance. So, like any a system that use like AI or machine learning or automation, okay, or log some personal data, okay, those systems affect people. So the standard this standard is relevant to those systems. Now, it is important to note that some outcomes might impact different groups in different ways. Okay, so we have to make sure that we could answer the question that does this system treat everyone equally? Or is there any bias into that are included in that system? Now, when we're dealing also with like a messy or like an unpredictable environment, it could be like self-driving cars or smart cities. Uh, this standard also comes in to deal with the real-world chaos that is included in this that specific technology's operation. Now, an example would be like a healthcare diagnostic system or technology or smart infrastructure. We have surveillance tech, as we mentioned, or autonomous even defense system. They're all making some decisions, some analysis that the result directly affect the users and the other people. Okay, so basically, if there is any involvement of the people with that technology, okay, now we have to cover the ethical requirement too. But it is not just a simple structure. Okay, it's not a random kind of like a structure and requirements. There is layered, okay, that apply to this IEEE 7000 series. Now, we have three main layers that are defined. Layer one is the foundational process framework. Now, in this level, basically the big picture method for designing requirement, actually the ethical requirement for the designing will kicks in, and it happened from the day one. Okay, so layer one include the general ethics within the design process. Okay, it is included and covered by IEEE 7000 itself. So please make sure that you don't confuse them. We have a series of standards that name IEEE 7000. Now, in that series, we have a specific standard, IEEE 7000, and there are several other standards that we are going to mention some of them. Now, the layer two is a functional ethical risk domain. What does that? This layer deal with the ethical risk, like bias or privacy or transparency. Okay, so it's basically zoom in into those hot spot, into where that we have a potential for breaking or like violating those ethical requirements. IEEE 7001 all the way to IEEE 7009. So 7001, 7002, all the way to 7009. These are some specific ethical problem classes that are defined based on the field. Okay, now layer three are for the emerging technology that we mentioned. Okay, so this is basically the ethics in a new and applied technology and context. Okay, so uh, we have new stuff like extended reality or algorithmic finance. Okay, and there are some very significant challenges when it comes to the ethical requirement of those new technologies and how they affect the people's life. Okay, now the IEEE 7011, 12, 13, 14, and 15 would cover these the requirement of these layers. Now, this is basically like a Lego. Okay, it takes what you need, and you can actually mix and match the requirement based on your system, see what you need from each of the layers, and then make yourself a very solid ethical kind of like system. Now, let's go a little bit closer to that main standard that we talked in this series, which is the IEEE 7000 itself. Now, this one is actually a general standard which gives a full process of how to figure out uh, all those values or all those requirements that is important, and then it helps you to kind of like turn those values that the stakeholder of those system that technology has into some engineering requirement. Okay, so it helps to find the people that are affected, those stakeholders that we mentioned, okay, by that system. So after that, we are going to map those stakeholders, okay, and model the impacts that our system could have on each individual member of those stakeholder groups. So basically, it's a diagram that shows how your system connects to the each of those stakeholders and their how it affects their lives. Okay, so the next part is that you have some values that you define for that system. It could be a fairness, it could be a privacy, it could be a transparency, all those values, ethical values. Now you need to basically translate them, turn them into an actual engineering requirement. So that's when the step requirement formulation would comes in. So it should be very specific. So all those requirements should be articulated very clearly and very specific. Based on there is a standard for those statement and articulation based on those IEEE standards. Okay, so there is no vagueness, there is no ambiguity when you want to like develop those specific requirements. Now, you have to check those requirements, okay, through the life cycle of your system and your product. So it's not just one thing, one time, one thing. Okay, so it should happen through the life cycle. So it's a continuous, repeatable validation. and verification. Now, this standard doesn't tell you what is right or wrong. It actually gives you a method that you can bring the people's, those stakeholders' values and make it an engineering requirement. So there is no mandation of like, okay, when we talk about like a privacy, this way is wrong, this way is right. No, there is some values defined by the stakeholders. Okay. And you have to, this standard actually create a method, a process that you can turn those values and those concerns into an engineering technical requirement. No, when you did that, now you have a traceable stuff like value profile and ethical requirement. Okay, so when you have that, you can prove that you actually followed the process properly. Okay, now we said IEEE 7000 itself is just a process. It's a general methodology for defining the ethical requirement and map the stakeholders. Now, we have individual standards for some specific concerns. Now, IEEE 7001 uh, is about transparency when we talk about autonomous system. So basically, the system should be able to explain their process and the decision making methodology, also their decision very clearly, so all the users and basically all the people involved with that system can understand it. Now there is another standard, IEEE 7002, that one covers data privacy. So it's basically, as you can imagine, it's define how we can collect data or use those data. Okay, so we can basically consent to some privacy tools and like workflows requirement. Now, IEEE 7003, that one covers the algorithmic bias. Okay, so this one basically tries to quantify and mitigate the biases in your system, the potential biases in your system. It could be a constant bias, or it could be a bias that is changing through the time. Okay, uh, we care about those because it would affect the fairness, okay, of our system. So we need to measure them and fix them if we have any bias in our system. 7003 would cover that. We have IEEE 7010 in that series, which is basically covers the well-being, the design that the concern is well-being of the stakeholders. So what we mean, so it helps you to measure how the system helping or harming peoples, and it's not just like physically, okay? It could be a mentally, it could be like a social health, okay? So each of those standards basically aim for different problem, okay? And those actually give us a practical way to handle those issues and concern. So it depends on what kind of system you are working on. So you can basically include some of those standards, some of those specific standards into your system. So if you don't collect like data, you don't need data privacy. So based on what you do, you need to mix and match and create like a puzzle. Put all those requirements that is applicable for your specific technology. Now let's go a little bit deeper into those standards. Like, starting with IEEE 7001, which is the transparency of autonomous system. Now, we have five big concepts in the IEEE 7001. The first one is explainability. Okay, and it is obvious what it means. So it's exactly what it sounds. Okay, so basically your system or your technology should have the ability to say to all the stakeholders, to tell to all the stakeholders to why that system did a certain process or a certain actuation. So anything that the system do, the system should be able to explain that to the users or all the stakeholders. Okay, and it should be clear. So basically, the goal is so we can make all the process and the decision made by the system, okay, all those decisions to make sense to the stakeholders, which are humans. Now, another factor is traceability. So when you want to like look back and reconstruct the steps that the system took, uh, your system should be able to have the traceability, have the logs for the internal processing chain. It's basically like a decision breadcrumb trail. Okay. Now we have predictability. So the behavior of the system should not be a random or a chaotic performance. So it should keep a consistent behavior. So when we, as a user, deal with that system, we can know actually what is to be expected from that system. So no surprises, no weird actions. The system should be predictable. We have auditability. That means if we have someone outside of the team, okay, the designing team, that person should be able to go into the details of our system and the technology that we develop and actually validate and audit what's happening in there. Okay, so this is basically for regulation purposes and creating a trust for the system. And the last one is the disclosure, which is being upfront about that what our system or a technology can do or cannot do. Okay, so you need to be clear. There is no hidden aspect of the system. Okay, all the process, all the specification of the system should be clear so everyone knows what's happening and everyone knows what is the system specification, configuration, and what to expect from that system. Now, let's talk about the transparency architecture. How we can make sure that we have a transparency. Here is basically how it happens. We have a decision logic. So that one actually record the data basically every time our system makes a choice. Okay, so those data could be inputs or the conditions or the internal states of the system. So it should basically keep the timestamp records, okay, for every decision and every step that the system took to make that decision. Okay, so we also have to have signed logs in that aspect. Okay, so the logs should be cryptographically signed. That way, we can make sure they are those logs are not tempered, so they are valid, kind of like unchanged data. Okay, so we can count on them. Now we have another component in our transparency architecture, which is the explanation interface. This one is basically help different people to understand those decisions and the process. So we might need like a full logic trace, okay? When users just need, as a developer, we need like a full logic trace, while those users only need like a clear sentence to know what happened. So we have explanation interface that has some like levels into it. Okay. The developer, the auditor have different expectation, needs different data from your system. User needs another kind of like type of data. Okay. Uh, from that system. Now, we also have model transparency reviews. These are some summary documents that basically explains how the system works, basically. So think of it like a user manual or regulators, researchers, and so all the people can check what is behind the scene. So when we put all those components together, now we have a setup that user can trust and know what's going on in our system. And also engineers can back up their decisions. Now, let's talk about the data privacy and IEEE 7002. This standard is about making sure that all the data that is recorded from the users in our system are respected and protected. So we have some privacy principles that says that, okay, we have to collect the data only if we need it. So no extra unnecessary data collection. We need to be clear about why we are collecting those data. And we also have to give the users the control. So this is their decision to give us the data or not. Okay, we have to be honest. And also, we have to keep all those data in a protected manner from all the like hacks or manipulation that could happen based on the recorded data. So it's actually like doing the privacy in a smart, respectable way. Now, how we can make it happen? IEEE 7002 has a workflow for this data privacy. One is the context mapping. Okay, so we have to figure out who is involved or what kind of data is being handled and what are the points that could have some threats and risk for our data privacy. Now, another aspect is the data flow analysis, which tracks how data moves through your system. It happens from the entry when you collect the data all the way to the storing data and actually deleting the data if in the end of the life cycle. We have some requirement specification. So we need to have a very good articulation, very clear articulation of exactly what privacy protection are needed, and it is defined based on, as we said, the stakeholders' concern and values. Now, we have a control design in our workflow, which is the method that we choose to for encryption or access control or differential privacy, which those control tools actually protect the data. Last one in the workflow of 7002 is the verification. So we did all those things. Now we have to check if we actually meeting the requirement. Okay, so we need to check that, okay, we apply the data privacy process. What did we do a good job? And is the actually we have are we have actually data privacy? Okay, so and this verification is not again a one-time thing. It should be through the evolvement of the system. So it's a continuous and frequent validation. Now, this IEEE 7002 also help you to align your system with the laws put in with by the regulators. It could be like a GDPR, CCPA, or HIPAA. Okay, so it's basically confirming the consistency with IEEE 7002 is a very smart legal kind of action that you can make to protect yourself later on. Now, let's go deeper into how that privacy design process works. There is a step-by-step workflow. One is the context mapping. Okay, so we have to figure out what world your system is operating in. So who is using it, or what type of data is involved, and on the other side, who might attack or misuse those data. We need to understand them and map them. Next step is data flow analysis. So we have to trace how the data travels. So, and as we said, it is not just one step and one part of the system. You should analyze that from the collection of the data to the storing of the data to when you process that data and all the way when you want to delete that data. So this is what we have to make sure that the flow of the data in our system is properly managed, so we have our privacy process actually applied to the system. Now, we have a privacy requirement specification that these are the values that we said that the stakeholders have, and we need to actually turn them into like a hard requirement without any vagueness. Ambiguity is not allowed in the requirement. And at the next step, we have control design, which is based on your system setup and the risk that you find. So you pick some specific tools for your security. It could be like encryption or whatever makes sense. Okay, so and lastly, you need to verify that. So you have to make sure all of those models and steps work properly. And you have to audit it. If there is a problem, you have to fix it. And this process is repeating continuously. Now, we also said there is another issue when we talk about the ethical system, and is a privacy issue. Sorry, is a bias, the algorithmic bias. Now, uh, it's not like a system should be like a corrupted or evil to have a bias. Okay, so it could be like a because of like a bad or incomplete data or some unintentional kind of like a problem that the designer didn't realize it. Okay, so IEEE 7003 basically defines some tools and give us some tools to find out those bias and try to fix it. Now, we have bias risk assessment defined by IEEE 7003, which basically is the process of looking for that usual bias. It could be like a sampling bias or measurement bias or automation bias. So anywhere that we have like an unfair assumption, okay, this could have like a bias in our system. So we need to realize them and find them. Now, next part is the mapping the data and intersectionality. So what that means, this is basically knowing and studying how the data flows and how like different social identities like race or gender or age could interact to create some bias. Okay, now we have to map them to soon we know, okay, we have a certain potential bias. We have to map them how they can get into our system. Now we have model level bias testing, which is a mathematical kind of like a step to check the fairness. We could check the demographic parity. There are things like demographic parity or equalized odds or predictive parity, which those math tools give us a quantitative kind of like way so we could evaluate the bias. After that, we have subgroup analysis. This one actually break down the performance by the group. So if your model is working better for some and it works like worse for others, you need to realize that and you need to fix it. We have another aspect, which is the bias drift monitoring. So this is about what we mentioned before of that some of the bias would change through the time. So we have to keep watching. Okay, so if there is a drift or like the biases that changes over the time, we need to realize them and fix them. So this is happening when our system has a learning based kind of like algorithm, like AI, basically. This is an example. Now, we have a real-time fairness dashboards, which is a tool that people can see the fairness metrics, okay, and challenge the bad decisions. So they can actually appeal against those problem in the fairness. And at the end, we have a full documentation. So we need to log the data set, data sheet, the design, the process, and like basically everything. So it should be traceable how we start with the input all the way until how we have the result that would affect that a user or stakeholders. Following this standard basically help us to build a system that is not just about the performance and working, is actually doing that performance fairly and in a responsible kind of like manner. Now, we have IEEE 7008, which covers the ethically driven nudging. Okay, so what is nudge? What we mean by nudge is basically some small like tricks that we put into the design that basically push people in a certain direction. Okay, but that push should not be forced. Okay, like we have like a default for our system. Like when you wanted to like subscribe for a certain kind of like app or service, normally they choose one of those subscription option as a default or mention it as a popular choice. Okay, so this is kind of like a nudge uh, design into the system, but they cannot force you to choose that. So you have still a freedom of choice. Okay, or when like the app has like like a specific software has like a very gentle reminder. So like there is an update, it would have like a notification that okay, there is a reminder that there is an update. Let's download that update. But it cannot, again, it cannot force you to do that. Now, those notch are powerful. So we need to make sure that they are ethically being used. So, as we said, a nudge should influence behavior without taking the choice or adding unnecessary pressure to the user. Okay, so ethical nudging means like being transparent. Okay, so what the nudge is doing, we need to explain that. We need to respect people's freedom of choice. We have to basically keeping the nudge in a user-centered manner. And plus, we need to make it easy for them to undo whatever we provide as a nudge. So it's not like, okay, you made a decision and it's done. They should be able to undo that decision. Now, there are some risk level. We have low risk nudge and high risk nudge. Low risk nudge are like friendly, like a default setting. We mentioned some of them. Now, high risk like nudge are like hyper targeted nudge that are based on the personal data. So they are more intense. Like one example is how the social medias like Facebook or Instagram, they use your internet exploring data, the cookies in your browser, to suggest some product and advertise some services. That's a high risk notch. Okay, so it needs more attention. This is more intense. Okay, and you can feel that like this. We are all sometimes, most of the time, actually, we are annoyed by those notches. So these are high risk notches that could basically violate the ethical requirement. Now, the final test for nudging is that understand who benefits from those nudge. Okay, so is that nudge good for user or is just for us to or the companies to sell some more stuff. Okay, so we need to ask ourselves that it is ethical to have that nudge or not. Now, what happens when things go wrong? Okay, now IEEE 7009 comes in. So we know that there is no system that is perfect. So stuff will break. But the question is, what happens when the system breaks down or have a problem? Now, what we have to do, we have to walk through some key process. One is a graceful degradation. So if the system starts failing, we shouldn't just crash or act unpredictably. So we have to scale back safety. Like we might shut down some features, but still some of the safe features that are under control is still accessible by the users. We have some ethical override. This is when like system goes real wrong. So system needs to prioritize the people's safety, those stakeholders' safety and values, okay, over the optimization or speed or profit. It doesn't matter. Maybe you need to slow down or even shut off your system. You have to do that ethical override to meet the requirement of IEEE 7000 series. Now we have an state awareness, which system should know what's going on. Okay, and like if something changed, it could be like a failure in a sensor or like some external risk. We have to know what's happened and we have to be able to adapt to that new condition. And system should do that on its own. We have uh, interruptibility. Okay, so a human or an external system should always be able to hit pause. And we should not make it like a drama. Okay, so they should have the control. If we can interrupt the system, basically we can actually control it. This is important. Now we have a post-failure forensic, which is also very important. So when a failure happened, when there is a problem happen, we need to, after that, we need to have a clear records of what went wrong, and we could trace back all those to the cause, the root cause. So we are able to actually fix it. So modify our system so we don't see that failure again. Okay, so this is basically this IEEE 7009 make sure that your system actually failed safely. Okay, so it's very important. Now, IEEE 7010 is another aspect, which is a well-being centric design, and it helps us to measure how our system actually affects the people's lives. Okay, so this standard gives some weight to different areas or different impacts that we can have on our stakeholders, users. One would be the mental or emotional health. The weight on this category is 25%. So what we ask ourselves in this category is that, is our system causing stress or anxiety or confusion? Okay, or it makes actually people to have a more stable or feel better. Okay, so this is one aspect. The next one is the physical health. The weight is 20%. So Does it physically harm people? This is the question that we have to ask. Or it support the safety, or like actually reduce the physical strain. This includes in this category. Third category is autonomy and control. The weight is 20%. And this is when we ask that, do users stay in control? So basically, can the user make their own choices? Do they have the freedom of choices, or we violated that? So we can't push people or trick them. Okay, this is covered in this category. Now, next one is a social connection. The weight is 15%, and it basically answers the question that, does our system help people connect, or it isolate them? Okay, so sometimes like we have like a collaboration aspect or community support. One very obvious example is like the algorithm in YouTube or Instagram and TikTok. When you post reels or like a video, how often it gets a view or liked. There is an algorithm that prioritize the videos to show them like for Instagram and Explore. So that as algorithm uh, falls into that social connection. So people might have like a need to feel that they are being seen, okay, and their contribution or their product are seen. Okay, so uh, to make sure there are requirements under this category, that algorithm is fair and actually ethically driven. Now, we have another category, skill and purpose. The weight is 10%. Okay, and it asks the question that, does the system helps user to learn anything or grow or accomplish anything or do something meaningful? So this is the question that we answer in the skill and purpose category. The last one is economic security, also has a 10% weight. And basically, it's talk about that if our system protect people financially or open some opportunities for them, or it actually creates some risk for the people. Now, these are not just some sort of like a fluff metrics. Okay, these categories are defined so it could help us to evaluate how the stakeholders are impacted with our technology and system. Now, let's tie everything together. Think of IEEE 7000 like a multi-layer ethical system. Okay, and each layer actually addresses different part of that, the experience that the stakeholder would have with that technology. Now, let's break it down. We have policy and process layer. Okay, the focus on this is values elicitation and stakeholders mapping. As we mentioned, the IEEE 7000 would cover that. We have the data governance layer, which covers the privacy, data ownership, and security. Okay, and it's about the protecting the data that people trust you to have it. We have decision logging a layer, uh, which is like this is the AI algorithm part, and it makes sure that the system is fair and transparent and explainable. Okay, IEEE 7001, 7003, and 7008 would cover this part. We have safety system, uh, which focus on a fail-safe operation and ethical override. We talked about that a little bit when we talked about IEEE 7009, which basically talk about how the system behaves when something goes wrong. And we have human outcome layers that makes sure that the final result is good for people. That well-being or dignity or autonomy part that we talk about. Okay, IEEE 7010 and 7011, there are a lot another also standards that would cover, but these two are the main one, would cover these aspects. Now, all those layers are connected, so you can't build ethical technology by just choosing one of them. So they influence each other. At the end, we have to mention that the IEEE 7000 is not just a checklist. It gives you a framework that you build into your system from the start all the way to the finish. So it could be in the design process, you have to use it in design process, you have to use it in development process, and you have to use it in deployment process. Okay? So this is our discussion for today. If you have any question, please let me know. Otherwise, thank you for your attention.